reading paper. I think this is from an academic IELTS exam, because of course the reading exams are different. The academic IELTS tends to be more scientific. I find they have a lot of quite scientific texts, maybe historical, geographical, maybe linguistic, but certainly they have a lot of science. I've seen a lot of chemistry and quite a lot of physics as well. And this one is about the scientific method. So we're going to look, I'm going to read through the text which they use for questions 29 to 40. So this is quite a large part of the reading paper. And I'm just going to go through the answers, but I'm going to try to show you how you can find the answers. So let's get going. This is called the scientific method. So let's read through. Hypotheses, said Medawar in 1964, are imaginative and inspirational in character. I like the parallel structure there, by the way, guys. Look at those adjectives starting with I, just paired. It's nice. In character, semicolon, because that's a main clause, and this is a main clause. They are adventures of the mind. If the writer had used a comma, it would have been a comma splice. So that's why that semicolon is there. It's between two main clauses. So they are adventures of the mind. He was arguing in favor of the position taken by Karl Popper in The Logic of Scientific Discovery, 1972, third edition, that the nature of scientific method is hypothetico-deductive and not, as is generally believed, inductive. I think this is very true, by the way. I quite enjoy this. I like this topic of what exactly the scientific method is, and I think it's true that many people misunderstand it. Okay, B, it is essential that you, as an intending researcher, understand the difference between these two interpretations of the research process so that you do not become discouraged or begin to suffer from a feeling of cheating or not going about it the right way. Now, this is a very important paragraph because this is really the writer's aim, yeah? And so it's a very important paragraph, and it will certainly come in handy later in one of the later questions. The myth of scientific method is that it is inductive, that the formulation of scientific theory starts with the basic raw evidence of the senses, simple, unbiased, unprejudiced observation. Out of these sensory data, commonly referred to as facts, you hear this word a lot nowadays, facts, yeah? Generalizations will form. The myth is that from a disorderly array of facts, yeah, of factual information, an orderly, relevant theory will somehow emerge. However, the starting point of induction is an impossible one. So we already see that the writer does not think that induction is involved in the scientific method. He seems to think that it's certainly not. It's certainly the hypothetico-deductive method. Okay, let's keep going. D, there is no such thing as an unbiased observation. Okay, this is why he's arguing against the inductive method, because the inductive method of just having facts and you being a neutral, unbiased observer is not the case. It's not true. So there's no such thing as an unbiased observation. Every act of observation we make is a function of what we have seen and otherwise experienced in the past. All scientific work of an experimental or exploratory nature starts with some expectation about the outcome. So it is already biased, it's already prejudiced. This expectation is a hypothesis. So a hypothesis is what makes it prejudiced, yeah? Expectation is a hypothesis. Hypotheses provide the initiative and incentive. Again, he's got double nouns beginning with in. The initiative and incentive for the inquiry and influence. Look at that, he's done it again. For the inquiry and influence, the method. Sorry, I thought that was double nouns, but it's not. For the inquiry and influence the method. It is in the light of an expectation that some observations are held to be relevant and some irrelevant, that one methodology is chosen and others discarded, that some experiments are conducted and others are not. Where is your naive, pure and objective researcher now? Okay, so you can see he thinks there's no such thing as an unbiased observation. Right, clear, and that's why he's arguing against the inductive method. Okay, let's keep going on to E. Hypotheses arise by guesswork or by inspiration, but having been formulated, they can and must be tested rigorously. using the appropriate methodology. If the predictions you make as a result of deducing certain consequences from your hypothesis are not shown to be correct, and I really do emphasize the not, and not are shown to be correct, are not shown to be correct, then you discard or modify your hypothesis. If the predictions turn out to be correct, then your hypothesis has been supported and may be retained for the moment until such time as some further test shows it not to be correct. So this is proving that there is no such thing as a fact for a start, because any hypothesis may turn out to be incorrect. Even some of the hypotheses we have about gravity, for example, been around for hundreds of years, we've recently changed in the last 100 years because they've been shown not to be correct. Okay, once you have arrived at your hypothesis, which is a product of your imagination, you then proceed to a strictly logical and rigorous process based upon deductive argument, hence the term hypothetico-deductive. Okay, so that's all of E. So don't worry if you have some idea of what your results will tell you before you even begin to collect data. Yeah, that's an interesting sentence. And then a semicolon, because otherwise it would be a comma splice. There are no scientists in existence who really wait until they have all the evidence in front of them before they try to work out what it might possibly mean. The closest we ever get to this situation is when something happens by accident. But even then, the researcher has to formulate a hypothesis to be tested before being sure that, for example, very famous example this, a mold might prove to be a successful antidote to bacterial infection. So I think he's referring to Alexander Fleming and penicillin. G, the myth of scientific method is not only that it is inductive, which we have seen is incorrect, but also that the hypothetico-deductive method proceeds in a step-by-step inevitable fashion. The hypothetico-deductive method describes the logical approach to much research work, but it does not describe the psychological behavior that brings it about. This is much more holistic, involving guesses, reworkings, corrections, blind alleys, and above all, inspiration in the deductive as well as the hypothetic component that is immediately apparent from reading the final thesis or published papers. These have been quite properly organized into a more serial logical order so that the worth of the output may be evaluated independently of the behavioral processes by which it was. It is the difference, for example, between, I feel like there should be a comma there, I don't know about you guys, between the academic papers with which Crick and Watson demonstrated the structure of the DNA molecule and the fascinating book, The Double Helix, in which Watson described how they did it. From this point of view, scientific method may more usefully be thought of as a way of writing up research rather than as a way of carrying it out. Okay, let's get on to the questions. So we're going to put headings first of all for C to G. Paragraph C to G, we've got to give the following headings. So we'll look at these headings in a second. There are 10 of them, and I think I might make the page a bit smaller to do that, but let's read C one more time. The myth of the scientific method is that it is inductive. Look at that word right there in the first sentence. And if you look down, it's there in the last sentence, induction, the process of induction. So it's going to be related to that, guys, right? The myth of scientific method is that it is inductive, that the formulation of scientific theory starts with the basic raw evidence of the senses, simple, unbiased, unprejudiced observation. So he's describing the inductive method. Out of these sensory data, commonly referred to as facts, generalizations will form. This is the inductive method. The myth is that from a disorderly array of facts, an orderly relevant theory will somehow emerge. However, the starting point of induction is an impossible one. So there's a lot about induction there. Let's go down and look at the list of headings. I'm going to have to zoom out a little bit. Yeah, I think that might make it a little bit easier. Maybe one more time. Okay, then we've got all 10 in view. Have we? No, we've got 9, typical. Well, let's just go through them anyway. The Crick and Watson approach to research. Crick and Watson are not mentioned. Get rid of it. Antidotes to bacterial infection. Not mentioned in this paragraph, yeah, as far as I remember, not mentioned antidotes to bacterial infection. I believe it was a bit further down. Let's find it. Where's that mold? Look, there it is in F. It mentions an antidote to bacterial infection, but it wasn't even the main thing in F. But it's not even here at all in C, so certainly not 1, certainly not 2. The testing of hypotheses. Well, it's didn't seem to be talking about the testing of hypotheses, which is the hypothetico-deductive method. It seemed to be talking about the inductive method the whole way through from start to finish. And look at number 4, explaining the inductive method. Sounds like a very good candidate to me. Yeah, it was in the first sentence. It was in the last sentence of that paragraph. The word induction sounds pretty good. Anticipating results before data is collected. Well, we haven't spoken about that yet. He certainly does soon. How research is done and how it is reported. Well, he's not talking about research here. He's not talking about a specific type of research. He's just talking about the inductive method the whole way through. He's explaining what it is. The role of hypotheses, well, that would be hypothetico-deductive. Deducing the consequence of hypotheses, again, that's about the other idea of how the scientific method works, which is hypothetico-deductive. Karl Popper, he's only in part B, so we know that that one's not going to be in any of them. In fact, was it even part A? Yeah, he's in part A, so he's not going to be in. We're not going to need that heading. We can already cross it off. It's definitely not going to be there. Yeah, and the unbiased researcher. So let's choose the obvious one for this one. Number 4, and I hope you can all see why I've chosen number 4 there. There's a very good reason. Yeah, let's go back up to the text, and I'll just remind you that it's giving it away. Look at it, inductive, induction, and all of this is what is inductive method. If somebody says what is the inductive method, you could say that sentence, that paragraph, yeah, and that would give them a good idea that it is when you start with the raw basic data of the senses and you assume that these facts, you can just take these facts and take an unprejudiced, unbiased observation. So yeah, we're going to go for 4 for part C. Let's try part D now. And I'll zoom back in again. Let's get a little bit better at doing things like this. There is no such thing as an unbiased observation. Every active observation we make is a function of what we have seen or experienced in the past. Yeah. So nothing's unbiased. All scientific work of an experimental or exploratory nature. Look, he loves this, X or X. He knows parallel structure, this guy. X adjective, X adjective. Experimental or exploratory nature starts with some expectation about the outcome. This expectation is a hypothesis. So this seems to be the main idea in this paragraph to me. It's all about a hypothesis. Now, quite a few of the titles had hypothesis in them, so we need to know which one. This expectation is a hypothesis. Hypotheses provide the initiative and incentive for the inquiry and influence the method. It is in the light of an expectation that some observations are held to be relevant and some irrelevant, that one methodology is chosen and others discarded, that some experiments are conducted and others are not. Do you see how crucial the hypothesis is? It's absolutely crucial, even though it's something that comes from inspiration. But it's absolutely crucial. It's vital. It's deduced as well, but it's something that comes with a certain amount of guesswork. Where is your naive, pure and objective researcher now? And this is the point, that nobody who is a scientist is naive, pure or objective. They all have prejudices, and we all do. And I could say this not just about scientific method, but also about a number of other topics as well. So let's get down to let's zoom out a little bit. Okay, here are our 10. We've got all 10 here. So Crick and Watson, again, get rid of them. They're just not here. They're only on the very last paragraph. So we might think about number 1 in the last paragraph, but not yet. That's still not mentioned, bacterial infection. So the testing of hypotheses. So are we talking about testing hypotheses here? Let's bear that in mind and compare it to some of the other ones. Number 4 has been used, so we've done that. Number 5, anticipating results before data is collected. Now, is that what we're doing here? Is the whole text about when we anticipate certain results before we've even had any data? That's certainly involved in making a hypothesis, but let's compare it to some of the later ones as well. How research is done and how it is reported. Well, not really about research. It's more about the hypothesis. This whole paragraph is about the hypothesis. The role of hypotheses in scientific research. Okay, let's compare this to the testing of hypotheses. Yeah, what do we think this paragraph is mostly about? Is it mostly about the testing of hypotheses or the role of hypotheses in scientific research? Let's have a look. So there is no such thing as an unbiased observation. Every active observation we make is a function of what we have seen or otherwise experienced in the past. All scientific work, okay, this seems to be mentioning scientific research, yeah, of an experimental or exploratory nature, starts with some expectation about the outcome, and this expectation is called the hypothesis. We really want to stick with the one about the role of the hypothesis in scientific work by the looks of things. Yeah, it's not about just testing hypotheses, but here this is about its role in scientific research. And that's why we mention a researcher in the last rhetorical question. It's a rhetorical question, that last part, and it's just making the point that there is no such thing as an unbiased researcher. So let's go for the one which has research in, it's about scientific research and the role of the hypotheses in scientific research. Let's choose 7 for D, yeah? Because if you come down here, deducing consequences of hypotheses, let's quickly check that one. Well, it wasn't about deducing the consequences of hypotheses. In fact, I wouldn't say that any of the texts are about deducing the consequences of hypotheses, because what you normally do is you deduce a way to test the hypotheses, to test that it's true. In other words, you try to disprove the hypotheses and not deduce the consequences of the hypotheses. Vague. Let's come back up to E now. Hypotheses arise by guesswork. Sorry, I'll make this a little bit bigger. Hypotheses arise by guesswork or by inspiration, but having been formulated, they can and must be tested rigorously. Okay, there's a bit about testing hypotheses. That's interesting. I don't know if some of you remember, but there was one of the titles below that said something about testing hypotheses. Using the appropriate methodology. If the predictions you make as a result of deducing certain consequences, okay, here we're mentioning deducing consequences from hypotheses. So if the predictions you make as a result of deducing certain consequences from your hypotheses are not shown to be correct, then you discard or modify your hypothesis. If the predictions turn out to be correct, then your hypothesis has been supported for the time being, yeah, and may be retained until such time as some further test shows it not to be correct. So any hypothesis that's already been shown to be correct could one day be shown to be false. It could be disproven one day. Once you have arrived at your hypothesis, which is a product of your imagination, you then proceed to strictly logical and rigorous process based upon deductive argument, hence the term hypothetico-deductive. So it's certainly talking about the hypothesis and how you and testing the hypothesis, yeah, must be tested rigorously. This seems to be the main idea that I can see as I just look at this. Let's now zoom out. One more. Okay, and again, we can get rid of 1, get rid of 2. We've already used 3. We've already used 4. Yeah, sorry, no, we haven't already used 3. The testing of hypotheses. This is the one which possibly is it certainly mentions the testing of hypotheses. So let's keep it for the moment. It's looking very good. Now let's have a look at number 4 we've used. Number 5, anticipating results before data is collected. We didn't really say that. The only other one that it didn't mention about research is done and how it's reported. We've used that one, number 7. The one other one was deducing the consequences of hypotheses. So is this about testing hypotheses or deducing the consequences of hypotheses? And you've got to look at the whole thing. Yeah, what is this about? Testing or deducing consequences? So let's look at the whole thing. We only mentioned deducing certain consequences here. And if we only mention it in terms of if the predictions you make as a result of deducing certain consequences from your hypothesis are not shown to be correct, yeah, not shown to be correct, then you discard or modify your hypothesis. So it doesn't seem to be the most important thing. It's far more important, this text is far more concerned with the idea that hypotheses must be tested rigorously, yeah? And at the end, once you have arrived at your hypothesis, which is a product of your imagination, you then proceed to a strictly logical and rigorous process of testing, yeah? Based upon deductive argument, hence the term hypothetico-deductive. So it's all about testing here. And look, you've got test again in the middle as some further tests shows it not to be correct, yeah? And it's all about modifying your hypothesis if you test it and it turns out to fail. It doesn't work, your hypothesis, yeah? So this is definitely number 3, the testing of hypotheses for E. Let's go on to F. So don't worry if you have some idea of what your results will tell you before you even begin to collect data. time are we on? We're on about 20 minutes. I think I'll just stop here and then we'll start again in 2